Okay, I want to say a few things about the midterm. So, in my undergrad experience, one of the things I hated the most was when a lecturer would say, oh yeah, this is easy, or I was afraid this was going to be too easy, and then it would be terrible, right? And I realized I literally did that on the exam, so sorry about that. Part of the reason why I said that was because I had it reviewed, and it was initially told to me that it was too easy, and I needed to make it more difficult, so I did make some of the parts more difficult. So I empathize with that. Like I said, that was one of the things I hated the most in my undergrad. And it shows me where there were concepts that I thought that I said in lecture that did not carry across into your guys' brains. So it is going to be curved, and but that doesn't mean that everyone did terrible. There were definitely parts, especially in the concept questions, where when people understood it, I could tell they got the answer right away and then just moved on to the next problem. And that's how it was supposed to be with the concept questions, but definitely people struggled with some of the concepts. But I think that's kind of a good thing for the sake of the exam, because it's kind of a litmus test of what concepts you guys understand and which ones you don't. And we are going to go over it, but not yet. I'm going to do that either on Wednesday or Friday because I need to continue going over this for your homework. And I'm going to move the homework to Thursday just so you guys have a little more time. But remember, that means homework 8 is due Monday, and the next homework is due Friday of the next week. So you're just going to have to do the next homework Friday, Saturday, Sunday. So it's going to be a little bit, a little less time for homework 8. But yeah, so just maybe try looking at both of them as well before the next homework is due. Okay, I think that's all the notes I wanted to go over before class. Last week, last Monday, we were doing this lecture, and then Friday was the exam, and Wednesday was a review session. So it's been a little while since you guys saw this, but we left off on this example, and I showed you guys, how you can find the velocity of B here because this link is rotating, and then you add that, you use the equation VA is equal to V B plus VA with respect to B. And that's all of rigid body kinematics. And then these are all vectors. And this guy was a cross product of omega link AB cross R, A with respect to B, so pointing from A to B. So that's where we left off. And I kind of made this its own example, but just without numbers. So what we're going to do this time is just do the same thing with this, with an actual problem. And this one's a little different than the last example. This example, it was just two rotating links, and we were given what the rotation was. So it was fairly, I don't want to say simple, but the process for this link was the same as the process for this link. Whereas with this guy, instead of being given rotational velocities, you're given the velocity just at d, and you have to figure out what everything else is. So let's just start. First of all, is there any questions about what I just said about how we did it on Monday, last Monday? Okay. So I'm just going to draw it over here. Okay, also when you guys draw these, remember how we talked about last time, always making sure you have a right-handed coordinate system. So I'm just going to say this is x and y. And always this direction is positive, right? You could, the only other option you could have is say this is y and this is x, but that doesn't really make sense for this problem. So the first thing I kind of want to start is just with this problem is just understanding what's going on with the problem. If you see that they tell you that link D is going upwards, which means that this bar is going to rotate something like this, right? And as it's rotating, it's going to go to some position like this, you know, when D is up like that. But because this is like the hypotenuse here, it's going to push B out this way. Does that make sense to people? So this link is also going to rotate this way, right? And if you didn't have link EB, this link here, then this wouldn't be fully constrained, right? This A and B could do anything they want, and D would just be moving one side. So one way you can think of it is kind of like the cable problems, or in statics when you have like a system of nodes in like a truss or whatever, where you do the sum of forces about each node. You get a force from each link, and then you can kind of systematically go through and solve it. It's pretty much the same thing, except instead of cables or nodes, you're doing it for each link. So you're going to find the angular velocity of each link and have an equation of motion for each link. So, so the point I was trying to make there is, if we do, what do they ask us to find first? The angular velocity of AD. So if we do VB is equal to VD plus VB with respect to D, then we still won't be able to find the velocity of B without also writing an equation for this link as well. So for example, VB is equal to VE plus VBE. So we have these two equations, and we can set them equal, and then we can find the velocity of B, or solve for the angular velocity of this link. So it's just having a system of equations and a system of unknowns. Also, these equations are vector equations, so this is technically 4 equations here, because there's one for x and one for y of each of these equations. So let's do the first one that I wrote here. For link ABD, we would get VB is equal to VD plus VBD. And does anyone remember how we found this on Monday? That was a long time ago. This is just omega cross R BD, right? So because this link is rotating, you're going to have VB is the velocity of the link of one end going up plus the rotation about that point. So it's as if you have D here. This is for VBD, and you have a link, and B is rotating about D, and D is fixed. That's what this term is. So this term plus this term is the total velocity of B, which is what we said last time is general plane motion. So if we say that this guy is unknown, we don't know what it is. We want to find what the angular velocity of ABD is. But this guy, we have the geometry here. we have 30 degrees, and the distance, I think it's 0.3, yeah, 0.36. So RBD is equal to negative 0.36 cosine theta, or cosine 30, I plus 0.36 sine 30 J plus 0K, because K is our angular term, right? We're not using it for a Z dimension. Does this make sense, how this is R? No? No? Okay, so we're looking at the R vector pointing at B from D. So this is our R, and we're crossing this with omega to get the velocity BD. And so this is 0.36, so sine 30 times 0.36 is the vertical height, and then cosine is the horizontal. And cosine is negative because we're going in the opposite direction of x. So we get RBD is equal to that, so we get VB is equal to VD, we're given, it's 1.6 J hat, it's going vertically, so we get 1.6 J hat plus omega cross 0.36 cosine 30 I hat plus 0.36 sine 30 J hat. And to find this determinant, or this cross product, we have to do the determinant. There are tricks we can do to avoid having to do the determinant on other ones, and we'll see that later. But this one, we're going to have to do that. So we're going to get VB is equal to 1.6 J plus determinant I, J, K of 0, 0, omega, and I'm going to start calling this omega ABD because we also have this link here, so I don't want to get them confused. And then we have negative 0.36 cos and 0.36 sine 30, and this is 0. And then if you do the determinant of that, just to give you guys a refresher, the way I do it is I cover this guy, multiply these two, subtract these two, and that's your I hat term, right? You guys should remember that. So this is equal to 1.6 J hat plus a minus omega ABD times 0.36 cosine 30 I hat plus, we're just moving down to the next line. Oh, this is sine, sorry. Cosine 30 J hat. So this is just the determinant of these guys, of this. So if we get this, we have one unknown, which is omega ABD, but we still can't solve it yet because this is just equal to VB. So we need another equation, and that equation is going to come from this link. And I'm just going to write it here. Link B, E. And that is, well, okay, first let me ask, does anybody know what direction the velocity of B is?
It would be negative x.
Yeah, it would be pointing this way, right? Because it's going in a circle, that's not a circle, but generally in a circle around E, right? Because this link can only rotate. So EB is fixing it to go horizontally this way, right? Which means there's no velocity in the y direction for point B. So what we can say is VB j hat is in the j hat direction is equal to 0. And so the equation that we got from this guy, all the j hat terms are just going to equal 0. So we can say that setting these equal, we get 0 j hat is equal to 1.6 j hat plus, what's actually a minus, omega a b d cosine 30. And we can solve, now we can solve for omega a b d and say that that is equal to, what did we get for that guy? 5.123 radians per second. Does that make sense how we found that? Or does somebody want me to go over that again?
Can you go?
Which part? Just like all of it, or?
Yeah, pretty much.
Okay. Okay. So what we started with was writing the equation for the velocity of B from this link, and we said that VB is equal to VD plus VB with respect to D, and this term is omega cross R B with respect to D. And this is just something, this part is just something you have to remember. Probably something you might want to put in your equation sheet. And then we did the same thing for this link, but we just intuitively said that the velocity of B in the y direction is 0 because we know this link is just rotating this way. We could have done this same exact thing for this link, but then we would have had to do a whole nother determinant. But since we know that there's 0 velocity here, we can just say that the y terms of the equation for this link and this link are equal. And so we just said 0 was equal to the determinant of this guy plus this 1.6 j hat. So, and then we were able to solve for omega ABD. And then now, since we have this omega, we can look at the I hat terms here and solve and just plug in omega ABD into the equation we got from VB, and then get both the I and j terms of VB. So if I plug in omega here, I get VB is equal to, let's see, what did I get that is equal to? Negative 0.924 meters per second I hat, and then yeah, oh no, this was just the magnitude. So, oh wait, yeah, because VB in y is 0. So this is VBX. And we got that it's negative in the negative direction, which means that it's going this way, right? Because we said positive x is this way. So there's 0 in y. So if you just plug this into the I hat terms, you get omega ABD cosine 30. Oh, that's j. you get omega ABD times 0.36 sine 30I, and that's your only I hat term, and then that just gives you this. So I do want to show you how you can do this link without just intuitively understanding it, understanding what it's doing. And the way you can do that is use the right-hand rule circle question.
Wait, how do you determine that the omega is a k?
Omega is just always k.
Oh, okay.
Yeah, so k in this class, k is not z. K is the rotational axis. So, and if you do this cross product for finding a velocity, and you get a k term in your velocity, that means you did something wrong. Because velocity, since we're in 2 dimensions, velocity will only ever have an I and a j term. Like if you have plus 3k, then you did something wrong. So there's never going to be a k term. Question?
Oh yeah, but why wasn't the j value omega 0.36 cosine?
The j value. You're talking about, oh, yeah, I just left that out. Good catch. And any other questions? No? Okay, so for link E, or link EB, instead of just intuitively looking at it, we can use the right-hand rule, the little triangle thing, where you go around in a circle like this, and this is positive. I always write this. So if we want to do omega EB cross R, and the reason, the reason we're doing this is because we said that VE or VB is equal to VE plus omega EB cross R E with respect to B. Right, so I'm just solving for I'm looking for the velocity of B with respect to E. So I get VB is equal to VE plus the cross product of the angular velocity and the radius. And the radius in this case is pointing from E to B. Whenever you're solving for the velocity of a point, your radius is pointing to that point from the point that you know. And we know the velocity of E, which is, does anyone know the velocity of E?
0.
Yeah, it's just 0, right? So the velocity of E is just 0. So we get VB is equal to omega EB cross R EB, E with respect to B. And the way we can do this is we know omega EB is K, is a K term, right? Because angular velocity is always K, that's what I was just saying. And we know intuitively that it's rotating this way, right? It's rotating clockwise, and we just said counterclockwise was positive. So this is negative K. And we're crossing that with EB, which has no I component in its vector because it's pointing straight down. So this guy is just J, and it's pointing down, so it's going to be a negative J. And so when we cross these, we look at this guy, we have a negative K cross a negative J, and we're going in this direction, which is the opposite. So we get a negative from here, and we get a negative from here, and we get a negative from here, so that's a triple negative. So we get negative K, or we get a negative times a negative times a negative I hat would be our answer. So we get a negative I hat for our direction. And this method is just for finding the direction of what your velocity vector will be without actually doing the determinant and solving it. And this negative I hat is pointing to the left, right? And that's exactly what we said intuitively when we said, oh, this link is rotating this way, this vector is going to be pointing this way. So that's this is another way to like kind of mathematically prove which direction the velocity is going, even if you automatically know, or if you don't know and you can't really intuitively figure it out, you can use this method to figure out the velocity. And one thing I will say is we can't really use it on this link because this link has both x and y terms, both I hat and j hat terms. So you wouldn't be able to say that this is just negative j hat, this REB, because it would have a j and a I hat term for this link. But if your link is vertical or horizontal and perpendicular to your velocity, you can do this. It also has to be perpendicular because you're crossing them, right? And you want your final velocity to be in one direction. Does that make sense? Okay. So we use that to say that VB was in the j direction was 0, and we plug that into our equation from this guy to get omega. And now I'm going to do the same thing to find for the last part of the problem where we find the velocity of A. So again, we're just going to start with the relative velocity equation. That's basically the fundamental of these problems. VA is equal to VD plus VA with respect to D. And this term is omega ABD cross R A to D. Right, and all these are vectors. We also know the velocity of B now, so we could also find A by saying VA is equal to VB plus VA with respect to B. We could do it either way. Does this make sense to why we can do both ways? Yes? No?
Can you say it one more time?
So we have the we're asked for the last part of the problem. We're asked for the velocity of A, right? So we can do the relative velocity equation. We have omega AVD, right? Because we just solved for that. So we could say, okay, we know this guy, and we can find velocity of A with respect to D because we know the geometry, right? But we also know the velocity of B because we just solved that. So we could go from B to from B to A instead of from D to A. It doesn't matter which one you pick. You can do either. So I did it from D. So what we can say, this guy is 1.6 J hat. We already know that guy. This guy is omega is 5.123 radians per second. And this R vector, this is probably the most difficult term to find, is this distance plus this distance is your R vector, so that's 0.6 meters times the first term for I is going to be cosine, negative cosine 30, because we're going the left direction. So that's our I hat term plus 0.6 sine 30 J hat. Does this make sense?
Yeah. That's right. But the EB part, shouldn't the subscripts be the other way? Or is it EB too?
Oh, you're right. This is VE. Yeah, good catch. The omega, it doesn't really matter because the omega is the same for anywhere on the link, right? But for the R vector, you're right. That VE should be switched because we're going to B from E. Did that clear up everything on that? Okay. So this is our R vector for this guy. And our A from D is equal to that guy. And so we do the cross product with this one again. So we get VA is equal to 1.6J plus determinant of I, J, K, and 0, 0, 5.123. And we just do the cross product of these guys, right? And that gives us, running out of room here, negative 5.123 times 0.6 sine 30 I hat plus 0.6 sine 30. Sorry, I'm running out of room. Let me move this over. It's not going to be in the video, but I'm just going to put it over here. And then that just gives us VA. I'm just going to write out VA for you guys. Maybe that'll be easier to follow. 37 I hat plus 1.062 J hat. And I'll write it over here as well. So the solution for VA is just the determinant of this guy, but don't forget you're adding the velocity of VD in the I direction, right? So the key thing to remember here is you can't just add these values like they're scalars. You have to add them in their vector components. Like this is an I term, and then you get an I and a J term from this, and you have to add those together. You could also write it like this: VA is equal to negative 1.537 comma 1.062, or VA is equal to negative 1.537 I hat plus 1.062 J hat. Either of these is the correct way, but you have to have a comma here if you don't have the I hat and J hat. Questions?
So going back to where you saw for omega ABD, that cosine 30 has to be in radians, right? 30.
Yes. Also.
I'm having trouble solving. I'm not getting that.
Okay, let me double check that I wrote everything right. Oh. Try it now.
Oh, okay.
Yeah, I just forgot the radius on there. That's all. Or the R vector magnitude. And this is why it doesn't have to be in radians, because you're calculating a distance here, right? This is a distance in the x or the y direction.
Oh, okay.
Right, so I just forgot to write the magnitude, the hypotenuse that we're multiplying cosine 35. Question?
Wouldn't the j hat value have to be negative because t is sliding up, therefore a is going down? I think I just did the calculation.
For A, for the
Yeah.
final,
I'm pretty sure it's negative point, or 1.062. I don't see how it would be able to.
the j hat, oh, it is negative. I forgot to put the negative. Yes, it is negative, and it's negative here. Yeah, so these are both negative. Any other questions? I think you guys having the time to solve it out is helping you understand it, catching all my mistakes too. So, yeah, no more questions?
Wait. Where do we get the angular velocity of EB?
We never actually solved for it.
Okay.
Because we said that the velocity in this direction is 0. So we're able to just say VBJ is equal to 0 and set it equal to the equation we got for this guy. And then we were able to find omega ABD without ever finding this omega. Also, I'll post my notes. I'm going to start posting my notes where I write out exactly what to say and I say the wrong thing. So you guys will be able to go over it and see what actually I was supposed to say. I think they're going to be a lot more helpful than the worked out notes that are already on Canvas. So, any more questions? Okay, I'm going to move on to the next thing, which is wheels, which is a special case for general plane motion. Are people okay if I erase yet? Any no's? Okay. Okay, so in problems with wheels, you're usually going to be given some angular velocity and some angular acceleration, alpha, and they're going to say that there's no slip here. And I'm going to call this point O, and this is point C. And if there's no slip here, what does this mean about point C on the wheel? If point C is on the wheel, what's the velocity of C? If this is the ground and the wheel is not slipping and it's rotating this way.
Yeah, it's 0, right?
Yeah, so the velocity of C is going to be 0 because it's not slipping and it's in contact with the stationary ground, right? And then, so we're going to have C here, O here, and what did I call this guy? A, and we're also going to look at B right here. So okay, one really important thing about C as well is that the velocity of C is 0, but the acceleration is not 0. And this is something that I heard is like a really big deal for people to remember, that if you don't remember, you get a lot of things wrong. The acceleration here, so VC is equal to 0. But the acceleration of C is not equal to 0. And we're going to look at the acceleration later, but essentially it's because C is rotating about O, and that gives you some angular acceleration pointing inward. Even though the velocity is 0, it's kind of a strange thing to think about. But, and also because this angular acceleration, you're going to get an acceleration this way. So, question?
Sorry, is C on the wheel or on the ground?
C is on the wheel. But because it's in contact with the ground, it's the same thing as not moving, right? It's the same thing as being with the ground at that instant.
So, but when it's accelerating, is that just saying like it's trying to move, but it doesn't have?
What he's trying to say is like, does C move with the wheel or not?
Yeah, C is moving with the wheel. The difficult, I guess the difficult conceptual, the difficult thing about about it conceptually is that just because your velocity is 0, your acceleration is not 0. Like you can have like a block like this that is moving this way, or that is not moving this way, v is equal to 0, but you're imparting some force, and at that instant, it's about to accelerate forward, or it's about to start moving forward. So it has an acceleration, but its velocity is 0. And it's the same thing with this guy. And I'll get into that more later, but I just wanted to cover that. So let's look at O first. What's the velocity of O going to be? We're rotating this way. Question?
Just in the X direction, right?
Yeah, it's just going to be going. It's just going to be moving this way, right? And the magnitude of that, if we look at this arc length here, then as this rotates, this point here is going to come onto the ground, right? And so this arc length is going to be the distance that it moves, which is going to be proportional to the distance that O moves. So we can say, displacement of O, SO, is equal to this arc length, which is R times theta. And the same thing for the velocity. The velocity of O is going to be equal to, well, let's put these in the right order. Theta dot cross R. But in this case, we already know it's pointing this way, so I'm just going to say theta dot times R I hat. Does this make sense how I got from here to here? We just already know from intuition that it's pointing this way, so I'm just multiplying the magnitudes here instead of doing them as vectors. And then the same thing for the acceleration of O is just going to be alpha times R I hat. I see a question mark on your face.
Oh.
Does that make sense?
Yeah.
Okay. And so this means that O at any given point in time is just going to be traveling in a straight line, whereas every other point on this circle is going to be going in general plane motion. It's going to be rotating about O and also translating. So if we look at A, for example, VA is going to equal, again, we're doing the same equation, VO plus VA with respect to O, and this becomes omega, which is the omega for the wheel that we're given, cross RA with respect to O. And this, again, we can just look at it intuitively. The velocity of A is going to be pointing to the right. And so this is just omega times RAO I hat. And what did we say for VO? We said that this was also omega times RAO I hat. So we get that VA is just twice the velocity of VO, which is 2 omega RAO I hat. Does that make sense why it's double VO? No? Okay, I'm just gonna explain that again. So VO we said is omega time the rotational velocity times the radius, right? Because we said this arc length thing here. And then so we have this term. This term, we're going from O to A. A is going in a circle around O. Essentially, if this term, like I said before, is as if O is not moving and A is traveling around O, and that velocity is just the angular velocity omega times r. So we get this, we add them together, and it's just 2 omega r. And then we can do the velocity of B as well. Does anyone have any idea what the velocity of B is going to look like?
Negative J component of V.
Well, it's going to be the same, but the components are going to be different, right? Because one is pointing down and one is pointing to the right, right? Because the first term, VO, is omega times r to the right, and then the second term, V with respect to O, is going to be omega times r pointing down, right? So we will get something that looks like this for VB. And let's see, let me make sure I'm not forgetting anything.
So it's square root of 2.
Yeah, however the hypotenuse works out, but yeah, it'd be VB, the magnitude is the square root of 2 omega. I didn't actually do this, so I'm probably going to make a mistake. Right?
Yeah.
Which is just the hypotenuse. So let me see if I'm forgetting anything. Okay, I'm going to say a little bit more about C. Again, why the acceleration of C was not 0. With these problems, it's important to find a point that you know the velocity and acceleration, and then do the velocity and acceleration of other points with respect to that point. So with O, it was fairly simple. We know it's moving in a straight line, and we said its acceleration. I put a theta here. This was the acceleration of O, and this was the velocity of O. So if we want to find the velocity of C, we could just go this way, but we already said C was 0. So, but if we wanted to find the acceleration of C, then we can do AC is equal to AO plus AC with respect to O. So one thing to know is this velocity equation also applies to acceleration. You can say the acceleration of C is equal to the acceleration of O plus acceleration of C with respect to O. And this, we did this on Monday, last Monday, which was a week ago, but we derived that this acceleration term is omega cross omega cross R plus alpha cross R C with respect to O. This term here is a lot longer than this term, like this for velocity. For velocity, it's just one cross product term. For acceleration, you have this term plus this term. You guys might want to just remember this or write this down, that the acceleration of one point with respect to another is this cross product plus this cross product. Where this is your tangential, and this is your normal. So it kind of looks like path, right, where this is v squared over rho, and this is alpha times r. And it is 9 o'clock, so I'll finish this on Wednesday. But yeah, question?
Could you say the tangential component one more time?
Sorry, can you not see this? Or?
No, not that well. Is that an omega that you drew? Omega cross?
No, it's alpha.
Oh, it's alpha.
It's alpha cross r.
Okay.
Is the maximum BB equal to that?
Yeah.
Thank you.
Okay.
Professor? Just curious, but like, what exactly does no slip entail conceptually?
It means that the wheel, like,
It's literally not slipping.
yeah, where do I have I need an example. If I take this thing and I rotate it, this is not slipping, but if I rotate it like that, that's slipping.
Oh.
Right, so,
I see.
like, its velocity at the bottom has to be equal to 0 because, yeah,
So,
like,
like
I could go like this and the angular velocity is 0 because it's slipping, right?
Okay, so like no slip means it rolls. Slip means it doesn't roll.
Well, it can, or if it's not slipping, it can be somewhere in between those two.
Oh.
It can be rolling a little bit, but translating faster than it's rolling, or slower than it's rolling because it's slipping.
Oh, okay.
Wait, Professor, I would say C wasn't moving, but then later we just said A is moving.